Welcome back. Let's start lectures. We want to start with lecture 1. Okay. Data and types, functions and algorithms, objects and classes, OO design, that is object oriented design. We are going to cover sections 1.1, 1.2, 1.3, 1.4 and 1.5 in this particular lecture. Okay. While it may seem like a large number of sections, they are not too, you will see it's not something very difficult. Okay, material. We'll go through this. There are two aspects of computing: data and operations. Data and types. All right. So computing involves keeping track of data. Data is information, right? And operations. Operations are what you do. Okay. What you want your different programs to use, basically. All right. To be able to so think of it this way: in English we talk about noun and verb. Data is um, information stored, whereas operations act on data. All right. Let's look at definition of data in the context of computing: the quantities, characters, or symbols on which operations are performed by computers and other automatic equipment, and which may be stored or transmitted in the form of electrical signals, records on magnetic tape, or punch cards, etc. That is data. Okay, so data is nothing but the quantities you have or characters you're working with, symbols on which all of these on which operations are to be performed. Okay, or you may store or transmit this information, these quantities, characters, symbols. That's your data. Within modern computers, all information is represented as a collection of binary digits. Binary digits are known as bits in short. Binary digit is a bit. Binary digits are bits. What is a bit? It is, well, you have two digits, 0 and 1. That's it. So you are in base 2. That's what binary digit means, base 2. Combining many bits, a wider variety of patterns can be stored to represent pieces of information. Okay, so you see, we use numbers as in 0, 1, 2, 3, 4 until 9. So starting from 0 until 9, you actually have 10 digits. The meaning of a digit is a finger. Digits are fingers. We have 10 fingers. That's why we naturally count in base 10. But base 10 is not necessarily the only way of counting. You can count in various bases, be 2, 3, 4, so on. Any base you can use. 0 and 1 are useful because for a computer, all it gets are electrical pulses. On, off, on, off, on, off. On is a 1, off is a 0. So because a computer has only electrical pulses to play with, it uses binary digits. All right. So binary digit, you're allowed only 0 or 1. Okay. Now this, right now it's only 1 digit each. That gives you only 2 pieces of information. If you have 5 places, then 2 to the 5. If you have 8 bits, then you have 2 to the 8 different values possible. What is set of 8 bits? It's called a byte. A byte is a set of 8 bits. It can represent 2 to the 8, that is 256 different values. With millions of bits, large amount of data can be stored. Much of the data being used by a computer processor is stored in the computer's main memory. Computer's main memory is referred to as random access memory. RAM, random access memory. Okay, so that is where you store much of the data being used by a processor. Okay, so this is a volatile memory. That is, once you switch off from the computer, it goes away. So main memory is where data is stored that you're going to play with, you're going to work with. Okay, it is the secondary memory where you save data that doesn't get lost. Even when you switch off the computer, you come back on, is a secondary memory. Which, and then there are portable memories also, like you have a memory stick or a CD and so on. Okay, so random access memory is the main memory where data is stored to be used by a computer processor. Now, information, what is the meaning of information for us? It is a high level abstraction. It's a high level abstraction, while data is a low level representation of such information. Okay. For example, number, I don't know, 256, that is information. Okay, that's a number 256. If I want to store it, then I would use in bit format. Now that is my data. Okay, data is low level representation of this information, capable of being stored and manipulated by a computer. That is, there could be several ways of representing information. Sorry. Each such choice of representation is an encoding. Okay, several ways of representing information, that is, each such choice of representation is an encoding. For example, JPEG, JPG and GIF are different encodings of the same picture. So one picture is just one piece of information, but how you store it, okay, that's encoding. Either you store your picture in the form of a JPEG file or a GIF file. Okay, so notice the point is information is different from data. All right, now data types. Though all data is stored as sequence of bits, it would be cumbersome to specify the exact encoding for every piece of data. Okay, so you can very well imagine you're writing these words. They are being saved in bit fashion, but I don't want to remember what sequence of bits represents letter B or letter I or letter T. I don't want to think about all that, right? So, higher level abstractions are supported through the definition of data types. What are data types? These are different types. For example, integer, that is a data type, which is different from floating point, which is different from string or user defined types. Okay, integer, notice integers are infinitely many. No matter how big your computer be, it doesn't have infinitely big memory. So you are going to have what is called int type. Do not, you see, there is a subtle difference between int and integer. Likewise, floating point. Floating points are where you are allowed decimals. Now, floating point is the best way to represent real numbers. But notice again, real numbers, there are real numbers with infinitely many decimal point values. Yeah. So, there is no way of getting, say, for example, number pi, which has infinite many decimal values. So what do? We have an approximation with decimals. So floating points are like real numbers, but not all real numbers can be represented here. All we get are approximations. What is a string? String is just a, as the name suggests, string of characters. So for example, words, they'll be string. User defined, this is where we come up with definition of class, so objects. User-defined types, these are called classes. Numbers, characters, dates, lists exist as predefined data types. These are often called primitive or built-in data types. So primitive or built-in data types are already defined within the programming language you use. Okay, we don't have to define. You see, we don't have to describe every number in the form of a bit or characters and so on. These are built in. All right. User defined types, on the other hand, are built by programmers who may want data abstractions. So these are called classes. Okay. So user defined types are built by programmers who may want data abstractions that are specific to his or her own implementation. Okay. So notice there is a difference between built-in and classes. User-defined types. User-defined are defined by you, the programmer, whereas built-in comes with the language that you use. Okay, so I don't want this lecture to get too long, this video to get too long, so I will stop it now and continue next.